now is we've come this far in making them with ASMO and able to walk up the stairs. How can we apply what we've learned in human walking to further advance ourselves? And there's no way. And my topic to you is on wearable robots and exactly how far we've reached in this stage. Okay, so a wearable robot is basically an electronic system that's designed around the shape and function of the human body, with segments and joints corresponding to those of the person it's externally coupled with. And you may be thinking that the idea for wearable robots has come from various science fiction novels. And basically, we have tried it before in the past, and the first one actually was developed by General Electric and the U.S. military in the 60s. It was called Hardyman. It allowed the user to lift up to 15,000 pounds, but it was not successful. This mainly because it weighed about 3 tons, and the amount of weight expected to lift was about 2/4 of it, so it really wasn't practical, and the movements were not very well controlled. So you would have violent movements, and you couldn't really expect a human to be inside testing it out, or else you'll cause damage to them. This is an image I found of Hardyman and what he looked like. As you can see, it's like pretty big, clumpy. You can't really move around easily with it. And so now, fast forward a couple of years, a couple of decades to the future, and the applications that we've learned from Hardyman are still there. Like, we still want advancement in strength and ability, and this leads us to two roles right now. We have military use and personal use, where military is just to advance soldiers in combat, make them more agile, make them better soldiers, and personal use in where we're bettering society in disabled, where we can make them walk again by affixing them with these robots. And here are some images of them. This is the U.S. Berkeley one, where this one has been used by the military, and it's basically leg structures that support the legs. This one, and there's a computer on the back, and basically this one, it's really works by manpower, and like he propels it, and the onboard computer just stabilizes the back motion, so he doesn't feel it as much, but it's still a good load on him. This next one is the Sarpos one that's currently being developed in Utah for the military. This one is actually a better one than the U.S. Berkeley one, since this one allows more flexible movement and easier movement too. I have a video on this one to show you guys. Just I'll do it at the end. As you can see, this one is tethered to a power source, so it's not really practical yet, but it's still in development phases. This is Cyberdyne's HAL 5. Cyberdyne. Cyberdyne HAL 5.
The company that made the Terminators?
Yes.
That's actually their name.
This one was actually developed by a Japanese professor, Sankai, in Tokyo. Basically, this model shown is a full body suit, which includes legs and arm attachments. And this one actually works by sensors. He studied the human body and how movement reacts, and he figured out that you send signals and they go through to your legs for motion, and he basically developed a suit that could interpret these motions before the person could actually carry them out. So in a sense, they actually this moves before the person moves and helps in powerlifting. Then. This is Honda's attempt at it that they've learned from their Asimov project. This one is still a prototype, and it functions the same way as the US Berkeley one, in a way. But this one features a seat in the middle. This is another one, robotic legs. This one is actually, I read that it was supposed to start going on sale for 2011. This one is basically for disabled or disabled people to help them get around. This one was one developed at MIT, similar in style to the Berkeley one, where it's just supported by the legs and has an onboard computer on the back attached with a battery. But some of the limitations of these suits are the power supply. You basically need a good amount of power to power the suits, and they usually tethered in testing until they could find a suitable power source. They have to make it strong but lightweight, so to allow the user to move around. This is accomplished mainly by using aluminum alloy, but they still have problems with that, so they need to refine it a bit more. Flexibility, that too. Then the movements need to be human, not too much robotic, just flowing. Same thing with power control and modulation, and unsafe movements tie in there too. I have some. Just into it here. Where'd it go? No, it's gone. Oh, there it is. Where should it send?
Oh, it's
How heavy was it? 40 kilograms?
Yeah.
Now look what happens if you tell a person who has been bound to a wheelchair wears the suit. She walks smoothly. It's amazing. I was surprised. This hospital in Yamaguchi, Western Japan, has been leasing this robot suit for about $2,000 per month. The staff hope the suit will help patients remember what it feels like to walk, leading to faster rehabilitation. Hifumi Fukushima, who is 74 years old, suffered a stroke twice. With his lower body paralyzed, he has been unable to walk for the past 5 years. But look at what happens when he wears the robot suit.
now you should pick up the box.